Hi, welcome to the F-Sync Gate talk. My name is Matthew Wilcox. I work for Microsoft on the Linux kernel, and if that phrase sounds as strange to you as it still does to me, great. I've been working on Linux 20 years, which means I've been working on the same damn computer program for 20 years, and it's still broken and still not finished, which is great. I've never contributed a single line of code to Postgres, but I do love you guys, and I admire the work you do, and I love it that we have all these free software databases. And I understand that you find Linux inconsistent and frustrating. That's okay, so do I. So when we get an I/O error, sometimes we might report it to you multiple times, sometimes we might not tell you about it at all. Sometimes permanent errors seem transient, even though we've actually already thrown away the data, or we've pretended the data's made it to disk and it hasn't. And even though we've said we've written the data, sometimes we throw it away anyway. This is awful, I know, I hate it too. Yeah. All right, so part of the problem, and I'm not saying you're doing anything wrong, part of the problem is that you were using buffered I/O. Other well-known large databases use direct I/O, so they don't use the page cache. So all of the problems that you have would be different problems if you were using direct I/O.
Boy, there's an example.
Sorry? Was that?
Is that the good news or the bad?
Good news or bad news? Yeah, well, different problems. You guys have different problems from the other big boy databases because they use direct I/O and you use buffered I/O. I'm not saying you're wrong. I'm saying you've made a choice and here are the consequences. So one of the things is that the page cache makes writes asynchronous for you. So you do a write, it hits the page cache says, yeah, I'll get around to writing that eventually, and then whenever Linux chooses to write it back, it will write that dirty data back to disk for you, and at that point it might detect an error. Obviously, some errors aren't detected at writes. Yeah, I mean, you know, if the drive fails sometime after the write was successful, that's not the kind of error we're talking about here. We're not talking about silent data corruptions that happen later. We're talking about the kind of errors which you can detect at write back. Like maybe I pulled the USB key out of my laptop, and the file's fine on the USB key. It's over here now. You can't do any damage to it, but the data that was written to that file is never going to make it, and the file that Linux is talking to now has an error in it, even though the actual file over here is perfectly safe. So most people don't realize that close can return an error. Most people do not check close for errors. Does Postgres, like when you close a file descriptor, do you check the return code? Okay.
There's a patch for that.
I would say we definitely assume after writing to a file, you need to check the close return value. As far as reading files, I'm not sure we're real.
Yeah. Okay, that's right. So for those who didn't hear that, if Postgres is doing a read from a file, it doesn't necessarily check the return value from close, and that's fine. I wouldn't expect you to. And the other comment over there was there's a patch to make sure that we do actually check, that Postgres does actually check the return value from close. One of the things, and you may not do this, but other programs do, is file descriptors can be closed for you without you actually calling close. If you call dup2, dup2 says, take this file descriptor and make that file descriptor refer to the same file. That will, if the other file descriptor is already referring to a file, that file descriptor will be implicitly closed. But there's no error return from it. You can't check it. So what you're supposed to do is call fsync, or fdatasync, or one of the other many pantheon of sync syscalls. And that should detect errors, and it will tell you, it will force a writeback, and it will report if any error occurred during writeback. So that's the ideal situation. There are good reasons not to do that all the time, but that's what's supposed to happen. So I thought I'd draw you a little picture of Linux data structures. This is massively simplified. There is so much more going on with this, but I wanted to fit all this on a slide, so here we go. So when you call open foo, we create a struct file. Struct file is a misnomer. What it means is open file. So every open file. When you have a file descriptor, a small integer, and you pass that to the kernel will look up that small integer and say, here is the struct file that refers to. So if you open the file twice, you get two struct files. Then we have a struct inode. The struct inode is what you all think of as a file. When I say, I created a file, what you mean is, I created an inode. Some other operating systems call this a vnode. It's complicated. I blame Koenig and Ritchie for all of this, and Thompson. He doesn't get away with it empty-handed either. But yeah, this is just historical baggage. It's too late to go back and change this now. So here's what we have. We have a struct file referring to our open file, and we have a struct inode referring to the thing that we actually think of as a file. And then we write to that file descriptor, and so we allocate a page in the page cache. And this one's got a good name. It's called a struct page, and it actually refers to a 4 kilobyte page of memory. It might not be 4 kilobytes if you're on Spark or something, but anyway, a 4 kilobyte page. And then we write to it again, and we write another 4K, and so that allocates a second struct page, because this is how write works. You've got your file script, you've got your offset within your struct file, so you keep writing to the file. So now we've got two struct pages hanging off the struct inode. And then we close the file descriptor. The struct file goes away, but the struct inode stays around. And the struct pages stay around until Linux decides to schedule writeback on them. If we run this program twice, and we pause it right before it closes, and by the way, you'll notice I didn't bother checking the error return from close here either. All right, yeah, this is slideware. I didn't type this into a compiler and copy and paste into my slides. I just hit keys on my keyboard at random, and it looked like C, so I said that's good enough. Yeah, so what I want you to realize is when you open the file twice, and each of these programs is executing in a different process, so we get two struct files, each pointing to the same struct inode, and they've both done a write to the same struct pages. Now, what Linux does not do is track who wrote each of those pages. I mean, it can't. This is a many-to-many relationship. Trying to keep track of that much information, it would just be overwhelming. And most of the time, nobody cares, because everything works. It's only when you hit an I/O error that you start to think, wait, who needs to know about that error? So back in 2016, this was the situation. We would hit an error while writing back that second struct page. And we would flag the inode, say, hey, we had an error. While we were doing a writeback, we hit an error. And it would sort of sit there. And then whichever of those two processes that had the inode open, called fsync first, got to see the error. And the other one didn't. Regardless of who wrote that page, only the person who asked about the error first got to see it. And my friend Jeff Layton said, this is silly. I mean, while we don't know who wrote it, surely everyone who has this file open wants to know about the error, because you've got a damaged file at this point, and having two people doing error recovery is better than one person doing error recovery and the other one thinking everything's fine. And that's good. That's good. This works. This is brilliant. But here is the genesis of fsync gate. A newly open file descriptor doesn't see the error. And the reason for that is that errors, so what we used to do back in 2016 was after the first file had called fsync, it would clear the error on the struct inode. So when the second person looked at the error state, they said, oh, nothing. But so now what we do for Linux 2017 was we would we have a counter in the inode. It's a very complicated little data structure, which is only a single word in size, but it allows us to store an error, whether anybody has seen the error, and what the last essentially clock count was that what the last sequence number was when the error was seen. And so the new struct file says, well, historically there was an error, but it was before I opened the file. So clearly I don't care about it because it wasn't my write that caused the error, so I don't need to care about it. That's not how Postgres works. And by the way, we regret the inconvenience. This is a bug, right? We have now fixed this bug. This is what we do. This is what we do now. A newly open file descriptor will only see the error if nobody else has seen it yet. So if you're in a situation where everyone has where the write back happened while nobody had the file open, the error sits unseen. We have one bit reserved in that little data structure for, has anyone seen this error? And so if nobody has seen the error, then the new file descriptor will get it. Which preserves the behavior as far as Postgres is concerned. So what Postgres is doing is it has worker processes which open their own file descriptors, do writes, close the file descriptor, or not, and then, but they're the ones who call fsync, or the master process calls fsync. The checkpointer calls fsync and expects to get back the error.
The worker processes tell the checkpointer which files they believe need to be fsync.
Yeah.
And then the checkpointer is like, oh, you want that guy fsync? I'll open it and call fsync for you.
Which works fine if Linux hasn't already done a write back. But if Linux already did the write back and encountered the error, the checkpointer doesn't get to see the error. It does now. We fixed it. But under extreme memory pressure, we might evict the inode, which can, because there's no file open pinning it in place. As far as Linux is concerned, nobody cares about this inode anymore because nobody's got it open. So if it looks to Linux like we would be better off using the memory that inode is currently occupying to hold another inode, or to hold page cache, or any of the other things that Linux might want to do, we will kick that inode out of memory and lose the error indicator. Because as far as we're concerned, you've told us, you've closed the file, you've told us you don't care about it anymore.
Actually, hitting this case would be extremely hard.
Hitting this case is extremely hard.
No, it took me like 5 minutes to work again. It turns out database is really hard.
But you would need not only for Linux to evict the inode, but you would need the backend to have the file open to evict it from that backend.
I just closed the backend.
Well, okay.
So Andres can be produced on demand, which is great, because apparently databases like to use all of memory. So if it's not being used for anything right now, then get rid of it. So this is something which still needs to be fixed. So we've got some options for fixing this. One that I forgot to write down here is actually for Linux to treat inodes which have errors as precious, so don't evict them. Pretend that the error indicator in that file is equivalent to somebody still having it open, because there's still information in that file that we want to have. But here's the problem with that. I just pulled this USB key out of my laptop. Maybe I had 1 billion files open on this, on this little USB stick. That's 1 billion inodes I now can't evict, and inodes are like 800 bytes or something. So, you know, when you're talking about...
That is a really high capacity USB stick.
you don't have... not that... Well, this one isn't, but you've got some pretty big USB sticks these days. And, of course, I mean, this...
1 billion inodes on one USB stick would be a lot.
It would be a lot, but of course, pretend this isn't a USB stick, pretend this is the other end of a fiber channel connector, pretend this is the other end of a SAS connector. Yeah, it can be big. I'm sorry, did you have a question?
I was going to say, could you not treat device gone differently?
Could you not treat device gone differently? Yes, and I actually have big plans in this area. I just don't have time to work on them right now. But so, I mean, these are some of the other so that was one possibility, but it's obviously not one that appeals to Linux people because we want to be able to evict inodes on demand. Right now, you can parse the kernel logs and see if there are errors on disks, and yeah, nobody's seriously asking databases to start opening up syslog and figuring out what the hell's going on. Well, we've been kicking around having like either per system or per file system or per device or per partition file descriptors, which we can use to then send errors back to user space in some easily parsed format. Dave Howells has a patch set that he sent out yesterday or the day before, which has a proposal for doing that. I would encourage, if you're interested in this kind of thing, go take a look at the Linux file system development mailing list, and the proposal is there. It's buried in the middle of like a 50 patch series that cleans up a whole bunch of different things. So maybe I'll forward it to the Postgres mailing list rather than forcing you all to go dig. What PG hackers?
Yeah, PGSQL hackers.
PGSQL hackers. Okay, I'll forward that there and hopefully start a discussion, a productive discussion. So that's one option. But we actually have a different problem, which I did mention on the first slide, which is what should we do with the data on error? In reading over the documentation of the summaries around what people had said and thought during fsyncgate, I discovered that there was a notion that if you called fsync twice, then the second time you called fsync, you would get a meaningful response. And that's not true of any Linux file system today. If you get an error back from fsync ever, that file is definitely toast somehow. You need to start doing data recovery at that point. I don't actually like either of the options I've listed in the first two bullet points here. One is ext4 leaves, so the data that you wrote stays in the page cache, but it's marked clean, so it will never get written back again unless you redirty that page, which you can only do by writing to that page. So that's awful, because now what's on disk is definitely not what's in the page cache, and that's bad. That's bad. But what
the system has no intention of fixing it.
It doesn't even know there's a problem anymore.
Yeah.
The error's gone.
Well, I mean, the system thinks that the error is there, it's clean.
Yeah, the system thinks the problem's fixed. Yeah. Woohoo! So the other option, I think, is, I don't know, it's also awful. Like, it just throws away the pages. So those pages are now marked. Now the file system thinks that those pages need to be brought back from disk. So now there's nothing in the page cache for those pages. The struct page is still allocated, but it's marked as being not up to date, which means that anytime you try and do a read or a write, it's going to try and pull in the latest version from disk. So if it's a transient error, you've just lost that write. You've lost that page which contained your write or your writes. So that's not great either, because we already said that write was successful. So that is a POSIX violation right there. But leaving the data marked as dirty will just result in re-reporting the same error every time we do write-back, which could be like a few seconds later. Yeah, it would.
I mean, what if somebody goes and fixes something? Are we really saying that
That's the problem.
no I/O error is ever transient? I mean, if there's an I/O error because somebody took the disk out and dropped it in a bonfire, then things are not going to get better, right? That data is gone.
It might be warmer.
But
Entropy has increased to maximum at that point.
but I have talked to some customers about this issue, and one customer in particular was like, well, we get all I/O errors all the time, and I go jiggle the fiber channel card or whatever, and then the problem goes away. Like, that's a little scary, but you know, that's their experience, right?
Yeah.
So they're like, oh gosh, if every time I hit an I/O error means that PostgreSQL has to basically crash and run recovery that might take 10 minutes, that's going to suck. Like, I just want to be told there's an I/O error, and then I want the system to stay up, and then I want to go jiggle the fiber channel connector or whatever it is that I do to make the problem go away, and then I want you to just finish all of the things that are progress. Which, to be honest, that all seems like a pretty reasonable thing to want. Not that
It seems completely insane.
I don't think it seems completely insane. I mean, it's not unproblematic because of these other issues with devices being pulled out and all these other considerations that you're talking about, but I don't know. Retrying things works a lot. Like, you know, there's, people click on a link and it doesn't work, and they don't say, oh gosh, I'm never going to be able to open this page. They just sit there clicking on the link over and over again, and very often, it works! Eventually,
So I'm
for no apparent reason,
curious
it
with
opens.
all the rest of the speaker slides.
Michael, you had a question.
So, in context of I/O error, does that include things like, well, the disk was full at this moment, okay, and someone could go and grow it, and the retry would work, but then you might say, okay, that's an error that you can really clearly see, but sometimes the disk is full because the thin provisioning underneath it is full, and someone actually is going to go and not just jiggle the micro channel, but put in some more spindles and expand the partition underneath, so that the drive actually gets bigger, or it gets more spare blocks to do things, and so actually that it's recoverable because someone did something, right?
You add a new RAID parallel, a new
Yeah.
So that something like that happens underneath.
Yeah, I mean, if that happens to you as a sysadmin, you have been ignoring a lot of warnings, and probably for days. So, yeah, I mean that's one of those situations where the Linux file system people have taken the position that you should not get into that kind of thin provisioning problem. How reasonable that is, I'm not entirely sure, but they hold this position quite strongly. Yes, Andreas.
Engineer said XFS will essentially just die internally, so it will not further corrupt the data. Just crash the OS.
But so writes that have happened won't actually get committed.
So even space in the APA, but
Yeah.
there basically just makes XFS die.
Yeah.
With panics.
I think you had another question.
So I walked in late, but you said you already mentioned this issue of like drives being pulled, back in the day there was umount-f,
Yes.
and Linux never had it, and it seemed like a fairly important thing to be missing. And now it seems this is kind of fallout from that. Like this is a workaround for the lack of this basic.
Actually, I see your, just for those who may not have heard the question, Linux doesn't have umount -f. And is this all kind of just trying to work around the lack of a umount minus f? So Linux does have umount minus f these days. Individual file systems may not handle it terribly well. It is certainly still possible to get yourself into an uninterruptible sleep. We have facilities for making sleeps not interruptible, but not every path in every file system is set up to take advantage of that. That's a simple matter of programming. I mean, the infrastructure is in place. It just requires somebody to go through and fix every single file system in every single way. But I do think we have a general problem in Linux around error handling and keeping transient errors transient rather than turning them into permanent errors, which is pretty much what we do right now. Yeah. So this is actually my last real slide. But I did want to pull the audience. Should we just mark the entire file as corrupted? I mean, should we just give up at this point? If we see an error in one page, how would people feel if we just said, you can never use this file again? If you want to do anything to this file again, delete it, recreate it. I mean, it's pretty extreme, but it would mean that you would be certain not to have corrupted data because you wouldn't have any data.
So you're talking about on writes.
On write, yeah. So
You have the data right now, but you can't figure out what to do with it. So I would expect the system in that scenario, pretty much always, the first instinct will be, well, I'll copy the file to some other device that I know is still good, or I think is still good, and if that copy succeeds, then I can restart Postgres over there, or add new code stripe, and Postgres doesn't even notice this, and then if that copy succeeds, I think I'm all good. So if you throw away the current buffer or throw away the whole file, I feel like, well, the current situation is the system thinks everything's all good, and in fact they're not. Whereas if you throw away the whole file, then at least the sysadmin knows they've lost their database.
yeah, if the sysadmin is using ext4 and they see an error and they copy the file over to a different device, then that's actually going to work.
Well, it's going to look like it works.
No, it actually will work because ext4 has kept your written data in the page cache. It just hasn't written it to storage.
So if
If you're lucky and you
Yeah.
copy the file before it gets evicted.
Well, presumably you've still got the file descriptor open at this point. You called fsync, but yes, good point. But with XFS or Btrfs, that's not going to work because the writes have been thrown away.
even if you have a file descriptor open,
Yes.
memory pressure.
Yeah, it doesn't matter. They upon seeing an error, they throw away your data.
Right, but even at ext4, if there's memory pressure, the page could get descriptor.
If there's memory pressure page. Yes, that's true. That's true. Yes. Yeah, that's right. Yeah.
So just to make sure I understand what's being discussed, when you say mark the file as corrupted, you don't mean on disk and persistently. So such that it can never be read.
I mean, yeah, so mark the file in memory as being corrupted. So you could reboot and try rereading the file, but you would not be able to read from it without perhaps having a special utility that knows how to say to the kernel, oh, hey, give me access. I appreciate you've thrown in the I/O. Give me access to it anywhere I want to try and do recovery.
But that's kind of okay, right? Because
Yeah.
you know, if you think of fsync as some kind of barrier, you know, on which we know that everything's on disk, if that never succeeded, then it's fine. You know, we don't believe that it has to be anything like that. We have recovery
Right.
facilities.
Right. That's a good point. Yeah.
My question is, which of those improvements are actually applicable to current systems? Right? Because right now we have systems in production. And if we implement something in kernel, which is going to be in production
So I can't tell you exactly which kernel versions had this behavior. I'm pretty sure it's up on the wiki exactly which kernel versions were affected by this. But yeah, I think there's probably about a year's worth of kernels that had this behavior. The first released kernel which has this behavior will be the next one out in 2-3 weeks' time. The patches for that are marked for backporting, so they will be in the stable kernels that are released soon. If you're using something like Red Hat or SUSE, ask them. I mean, we've tagged the patches for being backported, so and people who work at SUSE and Red Hat know about this problem and have been active participants. I mean, Jeff Layton actually works for Red Hat. The SUSE guys are also very much paying attention to this. They know about this behavior. They will have backported those patches. So I don't expect, if you're keeping your kernel up to date, and let's face it, there's going to be a new CPU floor out any day now that's going to force you to do a kernel update, you shouldn't be too badly affected by this current behavior, or this year-long behavior.
Is this in some ways better than the current behavior?
So this what do you mean when you say current behavior?
At least somebody will see more people see the error here than in the modern. The modern behavior, only one.
So in 2016, only one person saw the error. In 2017, we had the opportunity for 0 people to see the error, which, our bug, sorry. and now it's all fixed up, and at least one person should see the error if anybody asks about it.
But multiple people may see the error if they all have the FD open.
And retrying is still useless.
Retrying is still useless anyway. Like this is not even addressed. Like but Linux has been this way for 20 years. This is nothing new. You have already been suffering from this, and I suspect you haven't noticed. Computers are buggy, and sometimes I lose all my data, right? I mean, yeah, I mean, and again, this has been this way, again, for 20 plus years. So you're already living with this problem. Bruce.
Just to, for the egg on our face, we believe now there are some cases where we blame the hardware for some misconfiguration and told the user that, and we now realize that we may have been wrong in doing that. So we're a little, in some ways, us not understanding this has caused us to implicate others when we shouldn't have.
For anyone who didn't catch that, Bruce is issuing a mea culpa, saying that sometimes we may have been blaming hardware or may have been blaming misconfiguration, when in fact we were actually hitting some of these problems earlier. And yeah, we are human. And we are sorry. Obviously, we're not trying to make your life harder. We all want our users to keep their data. They seem quite attached to their data, and we would like them to keep it.
We've noticed that too.
Yeah. But you know, some of this is genuinely hard to solve because it's just a hard problem to solve. Like you just can't keep track of who wrote all the pages, and some of it's hard to solve because we've got some historical baggage, and that's on us, and we need to fix it. And I mean, some of this, I mean, I don't know other operating system kernels all that well, but I think it's fair to say that everybody struggles to handle errors in the best possible way. And I wouldn't be surprised to learn that Solaris, BSD, macOS, Windows have similar problems in some of these areas. I just haven't been and looked. I don't know.
Windows, same problem. We actually looked, I was going to say something else, but first, we actually looked, and interestingly, some of the BSDs behave this way, but some don't, depending, I guess, on how recently they wrote this. What I was saying before about ext4 and the memory pressure possibly meaning that that buffer was evicted.
Yeah.
More I think about it, like, since the user isn't going to know which file the error occurred on, their first instinct is usually, normally the best practice is to shut down the database and back up the whole database. So it actually seems really likely that any shared buffers, any file system buffers will get flushed and reread at some point. You're going to be rereading and writing gigabytes of data.
Yeah.
On the other hand, it creates a lot of memory pressure to write to another device you back up because you're doing it with
Yeah.
the CPU.
Yeah.
which is-
Yeah. I think you're saying the same thing, actually. Yeah.
Yeah, so it's very likely to flush out
Yeah.
this buffer that was not synced.
Yeah. Yes.
Could you explain a little bit more the reticence of the file system team to treat any errors as recoverable effectively, like in hardware level? Because it seems like, I mean, you can say like, well, you should have had warnings, but runaway writes are not impossible where it is not literally possible to get the data center to add drive space before you go from warning to error. And kind of on that, I'm wondering if like network errors on a SAN effectively fall into the same thing, because like a network error is obviously very likely to be resolved quickly.
Yeah, so SAN errors are treated pretty much like any local disk error, even though, as you say, they're more likely to actually be recoverable because somebody kicked out the fiber channel cable or whatever. And yeah, that's a problem. Like Linux just genuinely does not have good support for, oh, hey, this error is recoverable if only the sysadmin goes and takes some corrective action. Like I said, I do want to change that. I just haven't had the time because it's a big project in the end. The file system people are trying to balance a lot of different requirements. It is incredibly easy for them to create deadlocks where all of the memory in the system is allocated to these files and the file system is not writing them back because it can't, and then everything gets blocked behind this other thing and the system just falls over. So it is really, really tricky to handle these errors in, particularly when you consider errors are bursty, right? If you've got an error on one page and somebody's kicked out the network cable, everything you do is a waste of time at this point. Everything you do, until somebody goes and plugs the network cable back in, you can try as hard as you like, and you are not going to succeed. So you're just going to be wasting time trying to do anything. And so in the interest of keeping the system alive, it can be better just to throw away the data. Because we're not just talking about Postgres using the page, we're using buffer cache. Everybody uses the buffer cache for everything, except for the database that chooses to go off and do direct I/O, and then they get much more control over their own errors and all the problems that come with that. But it's hard to be general purpose. If you are building a special purpose database machine, then obviously we're doing the wrong thing. But we're not. We're building a general purpose operating system kernel and running a database on top of it. So that leads to a conflict handling. Andreas first.
I mean, one thing is also you might have layers on top that want to fail over to some other device. And if you suddenly block for 3 years in the kernel because nobody woke up and did something, because your company's done, nobody's care. And your problem as well. And like the ASI retries before it like goes to the OS level, to the file system level and says, hey, I'm giving up, it's retry. But like what I was originally trying to say is the XFS people want to handle the eno space thing in the kernel properly, so they handle whenever they fin provisioning case actually correctly. I think they even have patch sets now. I haven't quite understood them because I can't follow this. The traffic is too high.
I know, the traffic on mainnet is incredibly high. We outsourced archiving, and then the people we outsourced it to fell over. I like mark.info for my archives, but there's several out there. Yes, Robert.
It would be really nice to hear at some point, maybe we don't have time now, so maybe we can take an email, but it would be really nice to hear about what the different problems that we would have would be if we were doing direct I/O. Mind you, I'm not volunteering to write a patch this week that converts PostgreSQL to use direct I/O, but you know,
So it's a pretty long list, actually, from the research I've done. I mean, you know a lot about the physical hardware. If you're doing direct I/O correctly, and there's no easy way to query and get that information, so you don't have to have certain device support or have to use or configure things or no. Okay.
So you talk about raw I/O.
Yeah, that's a different thing.
Okay.
Yeah, in 3 minutes I'm not going to get through the ramifications of using direct I/O, but there are a lot. I've talked with the Samba people about them potentially using direct I/O, and they have a long list of the problems they have with direct I/O. The API was designed for a particular database, and you aren't it. You may consider them your biggest competitor, I don't know. Yeah. So I'll finish off by thanking Andres for coming along to LSFMM and being an awesome representative of this community to us, and I'm hoping to be almost as awesome as Andres. Jeff Layton, who actually did most of the work for doing the error handling, where you actually get to see the errors on every open file descriptor. I reviewed a lot of his patches, but he did most of the work. And I'd like to thank Dan for dropping onto the schedule at the last minute. We had somebody drop out, and fortunately we were able to have these 45 minutes together. So thank you all for attending.